Okay, for years, we have believed that ulcers are caused by acids and spicy foods because you get indigestion or heartburn when you have a lot of acids in your diet. So they, as doctors, have been treating this by telling us to not eat things that are acidic and spicy, and they would give us medicines, Tums, Tagamet, Pepcid, to reduce our stomach acid. But these two scientists down at the bottom of the page had been observing repeatedly that Helicobacter pylori, which is a type of bacteria, was found in most samples of ulcer tissue that they looked at. So that doesn't correlate with spicy, acidic food. So they saw in most of the ulcer tissue that they looked at that this bacteria was there. There were no other reasonable alternative hypotheses that had been supported. And so they started checking over and over and over and performing experiments, and that's what they found. So now the relationship between H. pylori bacteria and stomach ulcers follows the germ theory of disease. So this is a new way of explaining. It's a new theory about what causes our stomach ulcers. Now, let's look at these facts. Fruits and vegetables have vitamin C. And people that eat diets that have a lot of fruits and vegetables are usually healthier than people who do not. And we know that vitamin C is anti-inflammatory, and it makes our throat and our nose feel better. So taking that information and putting it all together, our hypothesis is consuming vitamin C decreases the risk of catching a cold. And we've observed, we've read about vitamin C. We know people that eat lots of fruits and vegetables are healthier. Scientists have told us this. Our doctor tells us this. We've had experience in the past. So all of that went together using inductive reasoning. That's how we came up with this hypothesis. So consuming vitamin C decreases the risk of catching a cold. That's a sensible hypothesis that we can test and prove to be false. So it's a good hypothesis. Now, looking at a hypothesis and how it needs to, we need to have some logic behind designing our experiment. Hypothesis testing is usually based on deductive reasoning, making a prediction. If our hypothesis is consuming vitamin C reduces the risk of catching a cold, then using deductive reasoning, if vitamin C reduces the risk of catching a cold, then people who take vitamin C supplements will experience fewer colds than people who do not. So we made an if-then statement. We can test that prediction. Now, why would inductive reasoning be better than deductive reasoning when we're making our hypothesis? Well, deductive reasoning is just a prediction. It's easy to test, but it's just a prediction. If the prediction turns out to be true and they do experience fewer colds than people that don't take the vitamin C, if it's true, then we don't reject the hypothesis. We're going to do some more testing. We might consider an alternative hypothesis that also helps explain this. But if we prove that in our experiment that people that took the vitamin C had the same number of colds as people that didn't, then we reject the hypothesis and have to come up with another one. Why is it impossible to say that the hypothesis that vitamin C prevents colds is true? Read through those. Look at number A, or letter A, sorry. You agree? Can you test that in the lab? Certainly. What about B? B is the answer to this question, because even though we have found in our experiment that the people that took the vitamin C had fewer colds, that might not explain everything that's going on. So we might need some alternative hypotheses to do some more testing. Because C, they do experiments with humans all the time. They're asking for volunteers that'll be tested with these new vaccines they're trying to come up with to treat this coronavirus. And we know letter D is not true, because we can get vitamin C by eating an orange. So we have to look at those alternative hypotheses. We may be closer to figuring out how to keep from getting a cold, but just taking vitamin C is not the whole picture. We need to look at other